Okay, so the biosynthesis of fatty acids. So this is biosynthesis means how fatty acids are made in our body. So our bodies will take some of our carbohydrates and or other fatty acids that we eat, but we'll take some of our carbohydrates and our body will transform those carbohydrates, strip away the water and leave the carbons and hydrogens, really strip away the oxygen and make these fatty acids. So enzymes, different processes in your cells will do this. And then again, we've talked about some of our essential fatty acids, which means that we can't make them ourselves and we need to get them from our diet. So typically this is not too much of an issue in adults with a regular kind of diet. You pretty much will get all of these, but two examples are linoleic acid and arachidonic acid. I'm not great at pronouncing these, I apologize. But these are those omega fatty acids that we need to get from our diet. So fatty acid and melting point. So just thinking about fats in general. So that's a lot of what fatty acids are, it's just fats. So if we're talking about, let's say olive oil is made out of the same, at least, well, not exactly the same, obviously, but it's made out of the same type molecule as, let's say, lard is made out of, or coconut oil is made out of. And both of those things, or all three of those things, have the same overall carboxylic acid long chain, but what changes is their melting point. So at olive oil or vegetable oil, stuff like that, that's always a liquid, it has slightly different properties in terms of its where the double bonds or how many double bonds there are, or how long the chain is, and that's what affects its solid or liquid properties. So for example, over here on the left, we have stearic acid. It's melting, it has 18 carbons, and its melting point is 69 degrees Celsius. So as you notice, there's these are saturated fatty acids, or stearic acid is a saturated fatty acid. So what will happen is, I'm going to underline it here. Saturated fatty acids, they have stronger intramolecular forces, so meaning forces, should say intermolecular, that is my bad. I was like, that's wrong. Stronger intermolecular forces, meaning the forces in between the different molecules, they have attractive and repulsive forces. And with a saturated fatty acid, we have stronger intermolecular forces, meaning that it's mostly a solid at room temp. So looking at the potato chips, the why they're there is, so things like this are going to be nice and aligned. So they have high intermolecular forces. So it's like when you get Pringles potato chips, they're all the same shape and they stack really nicely and really compress in together. If you can compress something where there's a lot of it in a small space, then you're going to get a solid. You're going to make it so that they're nice and aligned. There's not very much movement. They just kind of chill there as a solid. So just a general rule, as you have more carbons, as you have a higher number of carbons, you have a higher melting point with these. More carbons means more stuff kind of packed right in that same area. So you have a higher melting point because there's more intermolecular interactions. Now looking over at unsaturated, let's pick a different color, unsaturated fatty acids, such as this one over here on the side, which is oleic acid. Whoa, sorry. This is an 18-to-1, meaning that it's got 18 carbons with one double bond. So over here, we could have written 18-0. That was not a good 0. There we go. It's an 18 carbons with 1 double bond in there, and its melting point is 14 degrees Celsius. So just for reference, room temperature in Celsius is 23 to 25 degrees Celsius. So this is below room temp, meaning it will be a liquid at room temperature. And so this is where you can see what I was talking about with those bends. Those double bonds make it so that these fatty acids really can't stack on top of each other really well. They kind of just like wet noodles, kind of just mixed all together, or they look like these potato chips up here where they're all different shapes and they kind of just stack randomly all together. So unsaturated fatty acids have weaker intermolecular forces because of the different kinks at different places. So they're mostly liquids at room temperature. So the general rule for these is that as you get a higher number of carbons, the melting point actually lowers, because the higher number of carbons means the more kind of random it is. Kind of think about like if you have a bunch of small potato chips that are different shapes, they can stack pretty close together. But if you have really big potato chips, there's kind of more air in between, right? So you can't stack them quite as close. You can't push them near each other. So there's weaker intermolecular interactions there.